We are live, we are live. Awesome. Hello, hello. I'm just changing the music. I had dubstep earlier today, but now I am going to go with EDM, cause why not? Alright, my tea is getting ready. While that gets ready, I'm getting ready. And today is Advent of Code Day. Let me just put down the volume a little bit, tiny bit, you won't even notice. Alright, so let's get on with it. So we did part 1 sometime. Not in the previous stream, because in the previous stream I did Battlesnake. But now I am going to do the part 2. So a recap of part 1, you had different trees. Oh, was this the one that I had to do twice? It was, wasn't it? It was. Because the first thing that I did in this day for part 1 was to just do a bunch of maps and filters and filters and filters over filters like an idiot. So I had to completely redo that, and I ended up doing just 2 maps. Then I used every character and every character. Oh my god, stop doing that. Stop. I used every character for each one of these rows. Let me zoom in a little bit. Each one of these rows, so I can like check left and right. And then I did every to get the columns, which is up and down. So I don't even remember. This is a payload, what this was doing. Well, right now it's just counting, but let's remove the count by. And let's do this thing, cause... Oh, but I then had to... How was I troubleshooting this thing? I forgot. Anyway, let's not do that then. Let's see. Oh, I ended up with a bunch of true and false values and then just counted all of the true values. And I also had a flatten, because otherwise this was separated by, yeah, by each row. Okay, that's what I was doing. So I ended up counting first getting the edge, to know which ones were on the edge, then check if any of those were in the edges. So if X or Y were equal to 0, so like in the borders, or they were equal to the edges. Yeah, I keep forgetting that this one is on the opposite as Battlesnake, because Battlesnake starts here, so it goes 0 and 0, but this one starts here, so it is 0 and 0. So 0 and 0 and the edges, anything that touches those are on the edges, so cool. And then I did left first, so I got the line from 0 to x minus 1, and then every character... You know what? I'm gonna change the music. Turns out I'm not ready for EDM today. I need Lo-fi, because I need to chill. Yeah, that is better. Let's put another super fee. I don't know what that is. Cool. Okay. Now we're done. So now I have line 0 to x minus 1. and then check if every character like on the left has to be less than the tree. Then every character on the right has to be less than the tree for this to be true. And then if that's not true, then everything that's at the top has to be less than the tree, or everything that's at the bottom has to be less than the tree. So those were our stuff. So if any of those conditions were true, that meant that this tree could be seen from the outside thing. Whatever. If you don't know what I'm talking about, I'm gonna put it in the chat so you can just go and check it out and read it on your own. So I did that, and then here's a whole explanation of how this like example payload works. And in that example, the answer was 21. So I got to that 21. If I run this is 21, and I'm using the example payload. But then I had to use, where is the thing? Wait. I had to use another, where is the thing? Here. This payload. This huge ass payload. So if I put it here, it took a while, but it ran. So there you go. 1829. That was my answer. Turns out the input changes for everyone, so you don't just like copy the answer. So there's that. Then I have part 2, which I believe changed the whole thing. So the amount of tree cover available is fine. The elves just need to know the best spot. Oh, let me put this back. So I keep working with the example payload and not the huge payload, because I don't want to. The elves just need to know the best spot to build their tree house. They would like to be able to see a lot of trees. Oh yeah, I remember. So I had to measure the distance. Sweet. So for example here, we are at this 5, and it was saying, if you are if you are standing on this tree right here, and you look up, the view is not blocked, because you're a 5 and the other one is a 3. So it can see a total of 1 tree of height 3. Then if you looked left, this view is blocked immediately because there's a 5. So it can only see 1 tree, and so on. So now to the right, it can see 2 trees, and then down, it can see the tree, the 3, and then the 5. So it can see 2 trees. I'm just getting mixed with 3 and 3 and so on. Anyway, so then the tree of height 5, oh no, sorry. So now you have to find the tree's scenic score by multiplying together its viewing distance in each of the 4 directions. For example, this is 4 because you multiplied 1 times 1 times 2 times 2. You get 4. However, you can do even better, because why not? Consider the tree of height 5 in the middle of the 4th row here. So up is 2, and then left is 2, and then down is 1, and then right is 2. So the scenic score is 8. You have 2 times 2 times 1 times 2. So this is the ideal spot for the tree house. Consider each tree on your map. What is the highest scenic score possible for any tree? Okay, so now I have to get an array of numbers with the scenic score each. So before, I was getting this array of true and false. So now I have to get an array of numbers instead. So this is part 1 only. Oh my god, okay. Let's remove this. Oh, this was to kind of troubleshoot what the hell I was doing. Yeah, I don't think I need this anymore, but I'm gonna leave it there just in case. Okay, so in the edges I had x0, y0, x edge, y edge. I don't think I need that anymore, because I still need to count them. All of them, right? Yeah. Do I have to do only the ones that are in the middle? Okay. I am not sure. I'm gonna try first to do only the ones in the middle, because it's a mess for my code if I try to... Oh wait, no, I don't think it changes a lot actually. Okay. Okay, yeah, no, let's just do surround all of this in part 1. All of this is part 1. I'm gonna have to start from scratch. So I can go back to this to troubleshoot what the hell I was doing. Or maybe I can just base on this, I don't know, we'll see. Okay, so here we start part 2. And so first I'm gonna exclude the ones at the edges for now. Or should I? Maybe I shouldn't. Okay, let's start by the first one. Actually, I can just go here. Let's start by the 3. So I can check if x is at 0, I cannot go left. And if y is at 0, I cannot go top. So those are gonna be 0 and 0. Whew, okay. So I'm gonna add this in a comment first. Yeah, let's do the edges too, just in case, because I don't know. Okay, we start at this 3, at this tree number 3. And I need to count. I need an array. So I need to return a number instead of a boolean. Okay. So I should do variables probably. So let's do bar left. Let's just go in the order that I had there. Bar left equals, this has to be a number. Oh, actually I can remove this because I'm not running it. Sweet. So bar left is a number, and then I'm going to do left. This is just gonna be a bunch of ifs. So first, if x is 0, then this is 0, because I cannot go left because I'm at the left, right? X, yeah, X. If X is 0, then this is going to be 0. If this is not 0, like this one, then we're gonna count. So we are going to check line 0 to this, and this should return. Let me copy this and paste it. No, not here. Here. So I remember what this was doing. Now I can run this. I want to see what this does. Okay, so 0, 0, 0, 0. All of the first ones are zeros. Okay. Then we are doing line this from this. So the ones at the left are 3, and then 3, 0, and then 3, 0, 3, 7. Okay, cool. 1, 2, 3, 4, 5. There are 5. Sweet. Okay, we're going in the right direction. Now we have to check. Oh man, do I have to go one by one now? Oh no, I don't want to do reduce again. Because I have to check one by one, because I have to check the one that is closest. This is where I wonder if reduce is better than tail recursive, or if tail recursive is better than reduce. Oh boy. Because now I don't need every character, because I don't care if all of them are small. For example, like this should be 1, this should be 2. No. Yes, this should be 1, this should be 2, this should be 1, and this should be 1. Okay, I'm gonna do a tail recursive function. That's just easier for me. Function count trees. We're gonna start with this tree. Like, which one is this tree? And then next tree, and count. And count is gonna equal 0. So count trees. This tree in this case is gonna be a string, but this can also be a number. So let's start with a string. So I'm gonna send these to count trees and then putting the next tree. Okay, So this tree was tree, count trees, and then this is the next. Next trees. Yes, next trees. Or next tree. Damn it. I think I need to do x minus 1. I need to reverse this. X minus 1, 2, 0. Right. Let's try it. Let's just return these 3. Whatever. Oh no, it's not working. I wanted to... Oh, because I'm just returning... Oh no, it's next tree. Let's return next tree. Okay. So I'm returning it like the first one. Here is 3, 3, and then 0, and then 3, and then 3, 0, 3, and then 7, 3, 0, 3. Okay, yeah, that's what I wanted. Cool, 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 cool. So, all right, now I'm sending them. Now this is next trees. This is a string here. So now I need to take 1. So first of all, if next trees if next trees is empty, well, right now because it's a string, so if is empty, then I return count. If this is not empty, then I will check if next tree is 0. Let me do this for now. Okay, yeah, next tree is 0. So if next tree is 0, the first one is less than if this thing is less than this tree, then I can keep counting. Yes, so I can count trees again and do this tree. And now next trees is going to be 1, 2, minus 1. Oh, and count is gonna be count plus 1. Else this is gonna return count plus 1. Okay. One, 2, 3, 1, 0, 1, 1, 1. Okay, I don't know if that worked. So we're only doing left. So from this is 0, from this is 1, then from this is 2, then from this is 3, then from this is 1. Then we have 0, 1, 0, 1, 1, 1, 1, 1, 2, 0, 1, 1, 1, 2. Okay, let's assume that it's working. Cool, so we have that for the left. And we are always returning a number. Sweet, so this returns a number. Okay, so we get left. Now let's do right number. If now right is y, right? Right. Ha. Close to the edge. Yeah, if x, yeah, if x is the edge, if x is edge, then this is 0. Else tree, count trees, line, and then this will be -1, 2, and then this x plus 1. Yes. Okay. Now let's see how that works. So now at the right, we start here and we have 1, 2. Already starting bad. Okay. Let's troubleshoot. How was I troubleshooting? Oh, I want to see this first. Okay, so if I start here, to my right should be 0, 3, 7. Ah, I don't have to change this. Right. These 2 minus 1. I don't have to reverse these. Let's see. Oops, sorry. Ah, there you go. 0, 3, 7, 3, and then 3, 7, 3, 7, 3, 3. This should have been 0. Why isn't it 0? Oh, because, yeah, never mind. Okay, so right. Okay, so now I have, from here I have 2, from here I have 1, from here I have 1, from here I have 1, and then 0. And then from here I have 1, 1, 2, 1, 1, 2, 1. Okay, let's assume it's working. Left, right, then let's do top. That's gonna suck. Bar, you know what? I could have done variables with these two. I kind of want to go back and fix that though. Hold on. Let me fix it really quick. Because I don't want it. to stay like that. Really quickly, I swear. And then this thing. Okay. Bar, edges. And then this whole thing. That way I don't have to add the comments. Bar left, then this whole thing. Oops. And these are all booleans. Boolean. I'm also gonna see if it works, because maybe it doesn't. But right, boolean equals bar top, boolean equals, and bar bottom, boolean equals, oh come on, equals. And then I just do edges or left or right or top or bottom. And that should work with the 21. Let's just double check that it works with the other huge payload. .829. Okay, cool. So let's leave it like that, because that looks way better than whatever I had. So part 1, and then this whole thing. Oops. There. Now let's continue. Part 2. Yeah, way better. Okay. So we were checking right. Oh, what did I miss? Boolean but got number. Where? Oh, here. Okay. So now left, right, bar up, number. And at the end, we're gonna count all of this. No, we're gonna do a multiplication, right? That was the thing. All right, so up if y is 0, then do 0. Else tree, count trees. Oh, this is where I don't know if this is going to work. So let's see. Up, and then this is going to be left, right, top. Ah, top, not up. Top. Top. So I was doing this whole thing, and then I had to get the X from there. So if I do this, yes, all of these are zeros, and then all of these have 30373. Yeah, okay, and then I have to extract. Oh my god. Okay. So after that, I need to get the one in X. Right. No. Which one? So for the 2, this should be 3. For the 5, this should be 0. It should be. What am I missing? Oh, so I have to do another map? No. Ah. Okay, let's do this. This is count trees X. And then we're gonna do another one for Y. Because I don't want to redo this whole logic. I just want to create a new one. So fun count trees Y. This tree. And then this tree is still a string, I think. But the next trees is going to be an array of strings. Array of string, and then count 0. And this should return a number to, I don't even need the do. No, that's fine. Am I out of music? No, it's still going. Okay. All right, so now if let's do the same if is empty, just in case. Else if, oh wait, let me see first what is next trees, and then what I'm going to do. So tree count trees Y, and then this whole thing. So okay, I get the next trees, and first I have to go through each line and get all of the ones that are in this position. Is there an easier way to do that? I wonder. DataWeave array module. Count by, divide by. Maybe divide by. No. Drop. No. First with. First with. I can get the index. Maybe. Let's try this. Let's see if that works. Is there another one that would take? What about take? No, because it only takes the first ones. And take while. Maybe take a while. Let's try take while. Oh, but it's gonna check all of the other ones, right? Select elements from the array while the condition is met, but stops the selection process when it reaches an element that fails to satisfy the condition. Oh. No, that's not what I want. To select all elements that meet the condition, no. Okay, so first with, I think it's best. returns the first element that satisfies the condition, or returns null if no element meets the condition. But then this would have to go one by one. Oh no, but then when it reaches it, it stops. And if I do a map, I would have to go one by one. Oh, but can I do this tree? This tree is just a string, right? It's not the index. No. I will need also the index. Okay. Perhaps if I can get... Wait. If I can... else do this. Okay, so here it should only be 3, here it should only be 0. So let's try first with and then import this. Oh no. Import. Cool. Come on, remove the line. Thank you. First with, and then we have user index. So first with this. Maybe let me put it in parentheses. This equals, go away. And then this was top x. This was x. Will that work? No. Okay, let's see what this has. String to boolean. Oh, because I'm returning boolean. Dude, I don't care about that right now. Oh. What? Oh, I see. Okay, let's do map first to see what this is. And the index is 0, 0, 0, 0, 1. Ah. So I have to go through okay. I have to go through every single one of these. So here is where I would do the, where is it? Where, first with, the first with. So this is, hold on, map, and then this is the row. And then I would have to do row first with index 0, index x. Nope. Ah, index equals x. Nope. With these arguments, string function. Damn it. So my problem was that this was supposed to be strings instead of array. Append if missing, camelize, capitalize, char code. What is append if missing? No. collapse, count characters by, count matches. Collapse the strings into substrings of equal characters. Interesting. Count matches first. So maybe it's just first. Text, the string to process, amount. No, it just returns. I need to match the ones that from chart code, Hamming distance. No. Maybe just row X. And I'm overcomplicating things. Yeah, I was overcomplicating things. Well. So map this. Okay. And then from that, wait, this should be reduce. Reduce. And then I want to accumulate. Close. Zero, 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 and then I need 3, and then 0. So this thing plus the accumulator. No. Is it the other way around? The accumulator plus... Oh, plus, plus, plus. Plus, plus. Not 1 plus. Ah, that's also not what I wanted. Okay. Reduce. And this is... Wait, how was it? It was like this. This is map. Okay, so the item is the string, right? Yes, the item is a string. So reduce string, and the accumulator first will be an empty string, and then we'll do accumulator plus plus string. And if I do that, what happens? Okay. Oh my god. I don't think that's gonna work. Ah, this is X. Or yeah, I think it's gonna work. Okay, sweet. I don't know why it didn't work in the other way, but that's fine. So, okay. 30373. And then 32. Oh, I need this to be the other way around. 05357132. Yeah, I need this to be the other way around. I just hope this works and it doesn't send me a bunch of errors. Okay, like that. Okay, now we have 2, 3. So for 6 is 2, 3, 5, 0, 5, 3, 1, 7, 2, 3, and so on. 3623, and the last one is 9223. Okay. So we have that. Now we can send this string to the thing. Wait, can I just do this simpler? Because it's the same thing that I just did, isn't it? Or maybe because I need to start it. Let's try it just one more time. This is plus plus this. Yeah, no. Okay. Never mind then. So else tree count trees x, and then this whole thing, and now it should work. Okay, so first ones are 0, then 1. Well, actually all of them should be 1 1 1 1 1 1 1, and then 6 2 1 1 2 1. Okay, let's assume that it's working. I just hope I don't get the Stack Overflow error, because there's a lot of stuff and I don't need this anymore. And this can be y. Oh, sorry, this can be just count trees. Count trees. Count trees, count trees, count trees. Okay. Now bar, bottom, number. Number equals if, and now this is y equals h, then this is 0, else tree, count trees. Now I'm just gonna copy this whole thing, and now this is supposed to be 0 to, oh wait, let me check if this is okay first. Bottom, so I have this thing, so if I do this first, missing else, oops. Okay, I get, the last one is 0. Yes, the last one is 0. Cool. 2, okay, I get all of the rows, and then I need to do the reduce, and this might change. So for the 3, this is supposed to be 2 6 3 3. Okay, this is supposed to be the other way around. So let's do a plus plus this whole thing. There we go. So now we have 2 6 3 3 5 5 3 5. Cool. So there's that. Now I can put that whole thing there, here, and I can remove this. So now here in 3, this should be 1 2, then 1 1 1 2 3 4 1 2 3. Okay, sweet. The last one should be 0. Awesome. Whew. So now here is the fun part. So now we do left times right times top times bottom. Oh shit, because damn it. If you have 0, okay, so let's, instead of this being 0, let's do 1. 1, 1, 1. Okay. Cool. Now it shouldn't affect. So for example, here for these 3, we have nothing, nothing, and then we have 1, 2, and then we have 1, 2. So 2 times 2 is 4. Okay, sweet. So we have all of those, and now, by the way, I don't think I need any of these anymore, right? Not for this one at least. So count by is for the first part, split at, there's no split at, so I don't even need this. Every, okay, every I do need for the first part, first width, no, I don't need it. Right, split at, yeah, I didn't need it, okay. Then lines, I do need lines all the time. Every character, I do need it for the second part. Okay, good enough. So now I am going to do part 2. Well, and this is going to be max this. Oh, then max this. 16. Was that our answer? Oh no, it's 8. Oh no. So maybe I didn't need to count. Oh no. Huh. Oh well, it's not telling me the answer for the example. Okay, so which one is... which one has 16? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The 6. Because it has... let's see. It has 1 to the left, and then to the top it has 2, to the bottom it has 2, and to the right it has 1, 2, 3, 4. 16. Even if I did 2 times 2 times 4, it's still 16. Okay, so I think this is fine. The answer, no, the question is, do I even need to be counting the trees that are in the edge? So we'll see. Let's get our input and pray that it works. Oh my god. Okay, run. Running preview. Running preview. Oh, I forgot to do the max. Anyway, it worked. So that's great for my mental health. Okay, we got a number. Sweet, 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 sweet. Let's put the number where it belongs. Submit. Yes. 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 We did it, folks. We did it. I didn't believe in myself and you did. And I will be forever grateful with you. Now let me put that in the repo before I get rid of it. Hold on just a minute. I will just put it, copy and paste. I'm getting better at this. Okay. New folder, day 8. And then again, what was the... I always forget the folder structure. Inputs, new file, transform.dwl, and inside inputs, payload.txt. Okay, so my full payload is this monster, payload.txt, this whole thing, and my transform is this thing. Sweet. I'm proud. Awesome. Alright, so there's day 8. And then we can get rid of this. Day 9 it is. I'm scared. How much time do I have left? Oh, I still have like an hour. Cool. We can do this. Let me paste day 9 in the chat so you can check it out. Rope bridge. Okay, let's read this, and I'm gonna take a sip of my tea for a moment. Ah, it's falling. Don't fall. Small little tea. There you go. That wasn't so hard, was it? Okay. You aren't sure how old it is or whether it can even support your weight. Well, maybe don't get on it. I don't know, just well thought. Seems to support the elves just fine, though. The bridge spans a gorge, which was carved out by the massive river far beyond. I know I said I was going to just read this in silence, but I can't. It's just too funny. You step carefully, as you do. The ropes stretch and twist. You decide to distract yourself by modeling rope physics. Maybe you can even figure out where not to step. Consider a rope with a knot. I don't like where this is going. Consider a rope with a knot at each end. These knots mark the head and the tail. Oh no. I think I know where this is going. The head and the tail of the rope. If the head moves far enough away from the tail is pulled towards the head. Wait, what? Do I have some rope? I have a cable. Again, I'm a very visual person, so I kind of want to picture this. So, we have the thing, head and tail of the rope. Okay, so the microphone is the head and the connector is the tail. If the head moves far enough away from the tail, the tail is pulled towards the head. Okay, that makes sense. Due to nebulous reasoning involving Planck lengths, you should be able to model the positions of the knots on a two-dimensional grid. Then, by following a hypothetical series of motions, your puzzle input, for the head, you can determine how the tail will move. Day 9 is kind of like Battlesnake. Alright, awesome. I am glad. You can determine how the tail will move. Due to the aforementioned Planck lengths, the rope must be quite short. In fact, the head and tail must always be touching, diagonally adjacent, and even overlapping both count as touching. If the head is even 2 steps directly up, down, left, or right from the tail must also move 1 step in that direction so it remains close enough. Okay. Okay. Otherwise, if the head and tail aren't touching and aren't in the same row or column, the tail always moves 1 step diagonally to keep up. Okay, so head and tail, head, tail, head, tail. Okay, it moves diagonally. Okay, okay, okay. Okay, I can put away my snake, I guess. You just need to work out where the tail goes as the head follows a series of motions. Where the tail goes as the head follows a series of motions. Assume the head and the tail both start at the same position overlapping. For example, what is that? This series of motions moves the head right 4 steps, then up 4 steps, then left 3, then down 1, and so on. After each step, you'll need to update the position of the tail if the steps mean the head is no longer adjacent to the tail. Visually, these motions occur as follows. Well, this is a way better input than whatever nonsense they were doing before. Okay. So H covers T, and then we move right 4. Wait, what? What is S? S is a start. Okay, S is a start. Ah, we move 4 and it's showing me 1 by 1. Okay, so 1, and then 2, and then 3, and then 4. And then up 4, 1. Why did the tail not move with the head though? Because in these ones, the tail moved with the head immediately. So the tail should have moved here. Anyway, who am I to judge? So it moves here, moves up, because the tail is still in range. Oh! Right. Head and tail, head and tail, head and tail. And then... So also diagonal is fine. Yes, you're right. Then L3. Okay. 1, 2, 3. And then down 1. And then right 4. 1, 2. Oh, I see. 3, 4. Yeah, it didn't move here. Okay. And then down 1. And then left 5. And then it still stays where it is. And it moves until here. And then R2. H covers T. Okay, this looks fun. Yeah, it looks a lot like Battlesnake. It looks so fun. Okay, it ends up here. After simulating the rope, you can count up all the positions the tail visited at least once. What do you mean? In this diagram, S again marks the starting position, which the tail also visited, because it started there, and hashtag marks other positions the tail visited. So there are 13 positions the tail visited at least once. Oh no. Simulate your complete hypothetical series of motions. How many positions does the tail of the rope visit at least once? Okay. Doesn't sound too bad. Let's try it out. This is our input. And this also starts like in Battlesnake, right? Yeah. Starts 0, 0 here instead of here like we did in the last one. Cool. So this is our new text. Let's remove the whole mess for this one. Oh. Output application JSON. Payload. Run. And I can remove these now. Don't save. Okay. So how do I want to do this? Let's do coordinates like in Battlesnake first. Type coordinates equals, then we have x number. Did you finish day 8? I wasn't always there. Yeah, I just did, like a few minutes before you started talking in the chat. But don't worry, it was so fun. I already put my code here to be uploaded. I will upload it as soon as we're done, so you can check it out. But in theory, like, this is what I did in the part 1, which was just like doing a bunch of, I don't know, but it was returning booleans, so I basically just did an OR for all of them. And then for the part 2, I just did like a series of countings, and it took some seconds to run, but I didn't get Stack Overflow, so that's good. Remember that I was doing like filters and maps and a bunch of things. Not anymore. Nice. Yeah, you can check it out as soon as I push it. All right, so payload. Oh, I was doing the coordinates XY because I wanted to be like in Battlesnake. And then, well, let's name this point to change it a little bit, point. And then I will have head and tail, which are gonna be made of points. Okay, let's start by there. So if I do payload, do I want to do lines? Yeah, let's do lines, because lines is sophisticated, and we are sophisticated. Oh, I can enable auto preview now, yay! I wasn't doing it in the previous one because it was so much to do that I didn't want to overwhelm my Visual Studio Code. Okay, so now that, and then after doing the lines, oh wait, what happens if I do payload split by, can I do this? No, I can't. Also not this, nope. All right, lines it is. And then each one of these is a move. So let's do a function. Wait, let's do a type first. These are gonna be move. This can be right. Wait, let me do single quotes, just easier. Left, right, left, up and down. Right, left, up and down. Okay. And now, do I have to do one by one? I wonder. I could go through each one of the lines in a map. Map to, no. So map, and then this is a line. Ah, I'm like, why isn't it working? I missed the thing. Okay, so line. So now for every line, I want to see where this is going. So first I have R4. So line split by space. And the first one is going to be the direction. Maybe this is going to be direction. Okay, so let's do bar splits. And then split 0 is going to be direction. Bar direction equals that. Let's just do D. And then bar how many? This is going to be string. Let's leave it as string. And this is going to be splits 1. Okay, direction and how many. I may move this to a number eventually, but not yet. So now, for every one of these, I think I do need to. Okay. So I need 1, 2, 3, and 4. 1, 2, that. Okay. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 1. Okay, sweet. And now from each one of these, I will need to do one. Let's do a recursive function because I always do that. So function move, and the thing that I want to be doing is collecting where the tail has been. Okay. Okay, so move. And I need to keep track of the point where I'm at. So I'm gonna also do bar starting point, or well, S point. And this is a point. And this is going to be x0, y0. Okay. And it doesn't tell me how long this is, right? Like, where is the edge or whatever. Nope. Okay. So in this case, this was 13. Let's see. For moving, I will start at S point. I need the direction. I need the current point. Or first the current point, then the direction, and how many. No, I don't need the how many. I'm just gonna move one by one. So current point, direction, and then I need to send where the head is and where the tail is. So at the beginning, head will be at S point and tail will be at S point. Okay. So for each of these, I'm gonna call this thing, let me just return current point for now. Oh wait, current point also starting is going to be the S point. So fine, let's move this here. This is gonna be S point, no, S point. Or maybe I don't need current point and I just need head, yeah, okay. I just need head and tail, and let me return direction for now. Direction. So I'm gonna do move and then D. Okay, so for now I'm only doing this. Now I'm gonna move to the right. Oh wait, I'm missing the how many. How many map the move? And now, whoops. Move. No, move, a move. Okay. You call the function move with these arguments. Ah, shoot, it's direction. Direction? Direction. Okay. Why are you still sending me the thing? Expecting type direction but got string. What? Don't tell me that I had to use double quotes. Okay. But got range. Ah, fine, I'm gonna fix it. As range. No, sorry. As array. Oh, because okay, never mind. Let's remove you. Oh, come on. Remove it. There you go. Okay, no, I'm just gonna leave it like that. And you know what, this is just more complicated. How many? Now map, move. Okay, so now we have the number of moves that we're doing. And now we can move. So we get at the start point, and then I also need a function to make sure that I am near the head. Well, the tail is near the head. So function is near. And this is gonna get first whichever head is point and tail point. This is gonna return a boolean to okay. Oh yes, okay, you do work. So now how do I check Let me check my battle, my battle snake thing. Where is it? Where is it? Where I was doing the moving thing. Why do I have... What? Expecting type up but got any. I'm not gonna do that. Oh no, did I remove the thing? Oh, okay, here it is. Okay, so direction, and then here's how I move. Okay. Let's do the whole thing. Copy. Should I? No, wait. I can just do this with math, right? So head match and then case head dot x. Is there a... yeah. Okay, let's see this one for example. If head dot x is one less or one more, if tail.x is one less or one more than head.x, then they are near. If it is like more than one, then it's not near. Case. I'm just gonna do it with ifs because it's just easier for me. I know match is more sophisticated, but I am not a sophisticated person, so I don't care. Oh wait, maybe I don't even need if. I can just do the same thing that I was doing before. So var next to equals next to. So if head dot x. Oh wait, is there a way to check the difference? I want to try to do sophisticated stuff. I can't. Like a distance kind of thing. Math. Well, never mind. Wait in the core. Days between. Did I already know this existed? Yeah, I think so. Anyway. Wasn't there a distance? The distance. No. Well, never mind. Between? No. Okay. So head x. Let's do it manually then. Minus tail x. Let's take off the boolean for now to see what this returns. Is near. Head is near tail. Okay, so it's gonna be 0 right now because it's just at the starting point. But what if, let's say head is x 0 y 1, and then next to, no, is near x. So we're gonna do the same 0, and then y we're gonna do 2. Okay, and now if this is 1, okay, now we have -1. Let's do absolute. Should we do absolute? Like if this is 4, yeah, it's 4 points away. Yeah, let's just do absolute. Okay, so this has to be 1 or less than 1, right? If it's on the x. Sure. X distance. Okay, and then y distance head dot y minus tail dot y. So this is gonna be just 1. Yes. And then how do I know is the same, right? If I'm, for example, this is 0, 0, and this is 1, 1. Then this is still nearby. Yeah. Both are gonna be 1. Yes, so the distance is fine. So x distance is less than 2. Let's do less or equal to 1. Or y distance is less or equal to 1. All right. So I hope that works. If this is not near, then I have to move. Do I need to know in which direction? Maybe I do. But we'll get to there when we get to there. So we had direction then. First one is doing right. So first, let's move the head from the point to the right. So, do I need to create another one? Yes. Or no, oh no, this was the whole thing. Okay. So I'm gonna move right, which means my direction is right. Oh, this is where I was going to do, where is it? This thing. Yes. Now I'm gonna have to change it a little bit, oops, to match what I am doing now. Where was I? Here, okay. Okay, so direction match. And let's start with R. Well, no, let's keep the same ones. This was down, up, left, and right. So now, in case this is D, and then I want to update. Do I have a do? Yes. case this is T. I'm gonna move the head first, and then I'm gonna see if I need to move the tail later. So this is going to be head. So instead of initial, this is going to be head.x, head.y, -1, because I'm moving down. Then up is +1, left is x -1, and right else head. Okay, cool. So here we moved right, 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 right. I didn't move anyway. It's just the first one because we're not doing the thing yet. Okay, so move, we're moving. Return head. Yeah, maybe this should be its own thing. And what is it that I needed to get? I just need to know where tail is. Maybe for future improvements you can stream in multiple resolutions. I'm currently on mobile and it would be nice to lower the resolution to save data. I have no idea how to do that. But thanks for telling me. I will investigate how to do that. That's a very valid point. Okay, I still have like half an hour. Sweet. Thank you for that. I also think I'm gonna make the chat bigger because this is just very small. Anyway. So I'm returning head, but I should be returning where tail is. So first, this is the one from head. I don't know. I can only select. Ah, interesting. Let me take a note of that. And I write it in a notebook because I don't know why. Investigate how to stream in multiple res. Okay, thank you. Also, I realized why my computer was getting slow the other day. It's because my battery is draining so much, and I don't know why it says it's not charging. I don't know why it just doesn't charge. Like, you know, you're gonna lose your battery, computer. Why don't you charge? Oh no. Yeah. But oh well, that's just Apple, I guess. Anyway, so this is the direction of head. I feel like I should get another thing. Yeah. Okay, so this is not gonna be move. This is gonna be get tail points. So you are still on the charger. That's weird. Yeah, I am. Like, I don't have a charger per se, but I'm connected to two monitors. And those monitors are connected via USB-C, and the USB-C charges my computer. Like, you can see here in the icon that it is connected to the energy. It's just not charging right now for some reason. There's supposed to be like this intelligent thing that it knows when to charge and when to not charge. But I don't know how smart that is, because I mean, you're on 25% battery and you're not charging, dude. Like, what are you doing? But oh well, it's supposed to be smart. Okay, so I was changing this to get tail points, and then I'm gonna do another one that is actually move. And then direction. Seems very smart. Now that I think about it, like, it's kind of working like us humans. Like, I'm tired, maybe I should rest. No, let's keep working. Because why not? Sounds legit. Okay, and then point. Yes, let's do that instead. And now we're just gonna match the thing. There. Oh, instead of head, this is going to be point. There. Sweet. So now I can check. First we're gonna move head, bar, new head in the direction. So now move. Let me change this to the other side so it looks more legible. So head, move, direction. New head. Okay, so I moved 1 and 0. And after I move the head, I need to check if it's still near the tail. So new head is near tail. True. Still near, so I don't have to move it. Since I don't have to move it, I'm gonna return the current tail. Okay, and I need a new array of tail points. And this is going to start with S point, I guess. Or this is gonna start as an empty array. Let's start as an empty array. Okay, so if new head is near tail, then I don't need to move the tail. I can move on. And when does this stop? When there are no more directions. Will it ever stop? I don't think I need to stop because this is a map. I think so. Right? If I put here direction. Yeah. It's returning the whole thing. Okay, yeah. Okay, so new head is near tail. Wait. No. I do need to call it. Okay. I don't need to do the map. Right? Okay. Yeah. I know. I know what to do. Hold on. Okay, so how many here is gonna give me the numbers. And then I need to do the repeat. Is it in the strings? Strings repeat. Yes. Okay, string repeat number. Okay. So this is a number. Oh. Splits this. Okay. So D repeat import lines and repeat. Okay, there we go. This looks better. So now for every one of these, I'm gonna call the thing. And I'm gonna send each line. You know what? Let's do what is the opposite of split? Join by no. Oh, I have to do how was it from array to string? DataWeave cheat sheet. Array to string. Yeah, it was joined by. Why did you not work? Join by. Did I do something wrong? So it's the array, join by, yeah. Maybe I should have done parentheses. Should be joined by, yeah. Damn parentheses. I'm sure that was the issue. That was the issue, of course. Okay. Well, there we have it. So now that we have the whole string, we can get to it. So now I can do the then, or no, I think I can do it just like that. So I'm gonna send, this is gonna start here, get tail points, and I'm just gonna send the direction. Yes. So yeah, then get tail points, this. And yes, I am aware what I'm doing. So directions, this is gonna be a string now. And now I need to get var this direction, or like direction. And this should be a direction equals directions 0. Okay, so now direction, okay, we're good. And now we have new head move direction. Okay, so new head is near tail, true. There we go. So now if this is true, then we can keep moving the head without moving the tail, and we don't have to add the tail point. Only when we move the tail, oh no, because it's already there, right? If the tail is already there, should I just keep adding the tail to the tail points? I wonder. Or only when I move it, I can put the previous No. Okay. This is gonna start with S point. An array of containing S point. And then we're gonna keep moving. Every time that we move, we're gonna add one. Okay. So if this is true, first of all, if it's empty directions, then return, what was it? Tail points. Else, if new head is near tail, I don't need to move tail. So we do get tail points with the new directions, which is directions 1 to -1. The head is the new head. The tail stays the same. And the tail points is the same. Yes. You know what? I'm gonna put them in new lines so I can see all of them. Good enough. Else, get tail points. Our directions is gonna do the same thing, so let's add a new variable. Bar rest of directions. And this is gonna be directions, la la la. Let's. Oh, if I don't have to make this lazy, right? Should I though? Let's do it. In case I don't need it. So this is rest of directions. Or not. Let's not make it lazy. So let rest of directions. And then the head is gonna be the new head. It's always gonna move. And then the tail. The tail, if it's not near, oh, it has to move. I'm missing that. Okay, I'm gonna put tail for now, but putting a to do, move the tail closer to the head. And then if I move it, then the tail points, the new tail will have to be added. Okay. So this one is gonna be lazy in case I don't need to move it, so I don't get any mistakes. New tail. Let's put tail for now, and then move this thing here. And then new tail is gonna be here. And and tail points is going to be tail points plus new tail. I think you call the function move with these arguments. Object null. Okay, yeah, so that is gonna be a thing. So let's just do it right now. Lazy. You call the function dynamic selector with these arguments where rest of directions. Oh my god, you always make me put lazy stuff. There you go. Okay. Okay, so now we need to move the tail closer to the head. And I still have, how much time? I still have time. I think I can get this done. 0, 0, 0, 0, 0. It's just returning 0. Wait, what happens if I just return this and never do the plus? Oh. Okay. So it is adding correctly. Cool. So this was supposed to be 13. Are they 13? Let me just see. Then size of this. 15. Might be doing something wrong. 13. It was 15, right? Yeah. Well, we'll see. Okay, so let's move the tail closer to the head. So if this is too far away, then I need to move the tail, but in which direction is the question. So I have the is near. I will create another function. Fun. Which direction? So also head and tail, right? And now we want to see. So what if I do the same thing but without the absolute? Maybe that will tell me. X distance. Like this. Maybe it will tell me where I should be moving. Okay, so which direction? Let me just put it here. Where? Maybe I can just try it out in the DataWeave playground real quick. Just remove the point and the point. Okay. So first I have, let's say, x0, y0. No, 1, because this is the head. So this is the head, and then which direction, and then x0, y0. Okay, so this is returning 1 in x. Let's do this. X and y. Okay, so it's returning 1 in each direction. It's 1 to the x, 1 to the y. And it's ahead of me. Right. So then let's see one of the examples where it moved. So here, then moves here. It's still near. This is where I'm at right now. And then head moves to the right, which is x2, 2. Okay, so yes, it will tell me in which direction I should be moving. Oh wait, it's right. Yeah, 0, 1, 2, and it stays in 0. Yeah, 2, 0, 0, 0, So this is gonna tell me that I have to move to the Y. What if it's diagonal like this? So this is 0, 1, 2, 3, 4, and 1 up. This is 4 and 1, and I am at, let's say that I'm here. So I'm 0, 1, 2, and 0. 2 and 0. Okay. Okay, yeah, it's still gonna tell me that X is 2. Okay. So if X distance is more than or equal to 1. Oh, it's, yes, more than or equal to 1, then I have to move up. Then up. Else if X distance is less than or no, more than 1, then move up, because if it's 1, I don't care. If it's less than -1, then move down. I'm just trying to get this. Else this. Okay. So I have to move up. And I actually don't need this. And then I have to check Y. Y distance, right? This means it's up. Yes, this means it's up, and I should go up. I think. Else if Y distance is more than 1, Y distance is more than 1, then I should go right, I believe. Right. Else if Y distance is less than -1, then I feel like I'm doing something wrong, but let's see. Okay, so here it's telling me to go up. So if I go up, imagining that I'm here, oh no, I shouldn't go up, I should go right. Okay. Right, left, up, down, like that. Let's try it out. So this is here, and then this moves here. So it moves to 0, 1, 2, 2, 0, 2, 0, and I was at 0, 0. So I should move right. Okay. And then it keeps moving, so I keep moving with it. If it moves to 3, 1, and I'm already at 1, 0. Oh no, this is 0. This should be right. Okay. And then if it moves up, 2, 0, 0, 1, 2, 3, 4, 4 and 1, 4 and 1, and I am at 0, 1, 2, 3, 3, 0. It doesn't tell me anything. Damn it. It should tell me, oh no, because I am near. Okay, never mind. So I am near, but if I were one step behind, oh no, then it's gonna move. Oh, that's gonna be tricky because I need to move diagonally. Because then right there, I don't have to move. Then it moves one up, so Y 2 and X stays the same, and I have to move up. Crap. But then, so, oh, let's check the distances again. No. X distance, Y distance. So 4 and 2 is 0, 1, 2, 3, 4, and 2. So it's here. 0, 1, 2. And then I am at 3, 0. 0, 1, 2, 3, 0. Yes, so I have to move here. So I am here, and that is here. How will I know that I have to move diagonally? Because the distance, it's telling me that in the X, we're only one away. In the X, we're only one away. Yes, because it's still here. But in the other one, we're 2 away. 1, 2. And it's telling me to go what? Up, I think. To go up. But if I go up from here, oh, I will still be near actually. Yeah, because it's gonna still be diagonal. But then this doesn't expect me to move. No, this does expect me to move diagonally. But how will I know? Because technically the thing that I did which was moving up to here instead of to here, it will still work. Did I find a bug? Interesting. After simulating the rope, you can count up all the positions the tail visited at least once. I wonder if it will work even if I move here instead of moving here. Because, like, for example, this expects me to be 13 positions, but it was still good. It was still, like, fine. It didn't need to move here. It could have moved here and it will still be there. So maybe it's expecting me to move like, no, you have to move like that. Well, I guess so, but I think, does it say anywhere that that's where I have to be? Because it says must always be touching. Yeah. If the head is ever 2 steps directly up, left, or right from the tail must also move 1 step in that direction, so it remains close enough. Yes, that works. Otherwise, if the head and tail aren't touching and are in the same row of column, if the head and tail aren't touching and aren't in the same row or column, there it is. The tail always moves one step diagonally to keep up. Okay, there it is, there it is. Okay, if they are in the same row or column. There is our... No! Oh, this is starting to freak out because I'm almost out of battery. Damn you. And I have no more spaces to charge it up. I'm gonna have to end it here, folks, cause you're losing me. 4%.